Thank you for coming to my session on BI. I guess you must be somewhat interested in BI or not like all the other sessions. So first of all, my name is Ted Pattison. I live in the States, down in Tampa, Florida. I own a company called Critical Path Training. We do a lot of SharePoint training for developers, administrators, and now we're doing a lot of BI work. What we're going to cover today is really a very big picture of the strategy that Microsoft has for business intelligence and how the story has really shifted over the last 5 years. We're going to focus mainly on creating BI solutions if you're using Office 2013 and SharePoint 2013, but it would also be a disservice not to at least speak to Power BI and Microsoft's new initiatives in Office 365 that we're going to cover at the end. Okay. Now, another big theme that you'll see throughout my talk is that we're really kind of moving away from a traditional BI model over to a self-service BI model. So some of the tools that we all need to become familiar with if we're going to be participating in business intelligence projects on the Microsoft stack is working with things like Power Query, PowerPivot, Power View, and Power Map. So I want to give everyone a basic appreciation for what those tools are, as well as how you can use them inside of SharePoint. Now, let's just start with a very high-level question. What is business intelligence? It's taking millions of pieces of data and trying to distill them into information so that you can actually make decisions and take action in a timely fashion. Okay, so that means BI is not a bunch of drunk guys at a bar looking at a spreadsheet and said, why did we go out of business? So it's basically fast enough so that you can act on things. Getting the fact that revenue has to be higher than expenses to keep a business model going, but it can get so much more complex than that. Now, BI projects involve grabbing data, maybe from your transactional SQL Server database, maybe from another database, maybe from spreadsheets, maybe from mainframe downloads, but taking data from multiple sources and putting it together into one data set. And quite often it means, discovering where the data is, cleaning the data up, performing different transforms, modeling the data such that it's in an optimized format for doing reporting and visualization, and then basically creating visualizations on top of it. Visualization is just the fancy word we use for creating reports and dashboards. So let's start with traditional BI. So the BI world has this icon, a guy named Ralph Kimball, who became popular as of the late 80s, and he formalized this methodology, and it's become very popular. And the methodology is something that creates projects of a very large scope. And when a company comes in and starts consulting, the basic expectation they set is it's going to be a year before we give you anything useful. Plus, we're going to need 10 people. We're going to basically talk to your users for the first 3 months. So there's a really lengthy requirements gathering phase. Typically, we're going to take the data and we're going to build the data warehouse. So there's a lot of database geeks that have to get in, as far as people that know how to use different SQL tools like integration services. People have to know how to model the database. Then people basically have to be brought in, typically at the developer level, to build multi-dimensional cubes. So while this methodology is perfect for a certain number or certain percentage of the projects, it's not great for many others. So when I need to have data or BI results in the next month, it's not a good project for that. Small to medium-sized companies that can't write 100,000-pound checks, it's not a good methodology for them. To add salt to the wound, so many of these projects that go through these huge year-long, 2-year projects end up failing and canceling with no net result to the company. So that's one of the things that we're looking at. Now, a little bit of background. Sometimes data is in what we call online transaction processing, OLTP, a transactional database, an operational database. There's lots of terms for it. But the idea is, as your salespeople are hammering in information, it basically gets stored in some database that's been highly normalized for things like inserts and updates and not for running large queries. But generally, that's where the data is that we need to analyze. And sometimes my BI project just has me look at a single transactional database. But sometimes it's a sales database, but then I need to go to the manufacturing database or the operations database and intermix data. So things can get fairly complicated. And what we see is that these online transaction processing systems have to be optimized for fast entry, so they're just not good candidates for doing reporting directly on top of them. Well, then we have the online analytical processing systems. So generally, to take the strain off the users that are adding data, we have some type of approach where we're running queries and basically taking copies of the data, maybe transforming it, to switch 11 tables into 3 summary tables. But the idea is OLAP databases are read-only. Generally, we have bulk transfers of the data inside them, and there's many different types. So one thing that we see is that what gets to be very common in the larger BI methodologies is that we build a data warehouse. So what do data warehouses give us? They allow us to take data from multiple sources, put it all in one place, so it makes it much easier to create reporting systems and dashboards on top of that. Quite often data lives in lots of places that has hairy security requirements to get inside there. So pulling the data out, putting it inside of a single SQL Server database that are a data warehouse certainly makes it a lot easier to configure permissions for users to get there. We can denormalize the data, so instead of running a 3-way join, quite often you can basically run it on a single table, and the table can have indexes that are optimized for data retrieval, not for inserts. So we just get a much better world. The one other thing about creating a data warehouse is quite often we want to start tracking historical data. As an example, let's say that you have a sales database and you have a customer. Customer lives in London, makes 10 purchases. Okay, customer moves to Paris, makes an 11th purchase, and we update the database to say the customer now lives in France, not the UK. And as we run the report, all 11 transactions get allocated to the UK or to France, not the UK. So one of the reasons that we sometimes have a requirement to build a data warehouse is to start adding things into the data model that track historical things that are important that were not important to the people who are modeling these online transaction processing style databases. Now, one of the big propositions with the self-service BI we're going to look at is the data warehouse is optional. And I think if you look at traditional BI, it was never optional for various reasons. And what we see about the data warehouse is if it's required, you got to have it, but realize how expensive, both in cost and time, it's going to take to build that thing. Okay. Now, if we look at just the Microsoft Toolset, well, they have the database engine for building transactional databases and also for building the data warehouse itself. You have SQL Server integration services, which basically gives you the extract, transform, load capabilities to pull data out of various places and load it into your data warehouse. And it's a very advanced product, and you can do amazing things with it. But once again, requires a very skilled developer to be able to navigate through figuring out how to build the SSIS packages to build the data warehouse. You have SQL Server analysis services, which allows us to build OLAP databases that are beyond just traditional relational databases. So we've had multi-dimensional databases that have cubes. You've probably heard about those. And we now also have the ability to create a second type of OLAP database, which is a tabular database that we're going to talk about. Finally, we have SQL Server reporting services, which is a tool that there's both an end user report builder utility, and there is support in Visual Studio to basically build reports on regular databases and multi-dimensional databases inside there. Okay, so just kind of finishing off our historic look back, if we go back to something like SharePoint 2010, before we had all these advancements in self-service BI that I'm about to speak to, here was what people at Microsoft would recommend. Well, we go ahead and we'd bring in the 10 consultants, and they'd all get in residence inns and basically stay there for a year on our dime. And they'd build the data warehouse, and then they'd build multi-dimensional cubes, and then we'd use things like Excel 2010, Excel services, performance point services, and SQL Server reporting services to start building our reporting layer on top of that. Okay, so now what we're going to look at is this huge shift that's occurred not just within Microsoft, but industry-wide when we think about BI support. So self-service BI, the very term, wasn't coined by the big vendors. We can really look to something like Tableau or ClickView and probably a handful of other small vendors that started doing things that allowed companies to very quickly navigate their way to creating BI dashboards, whether it's based on cubes or based on just pulling data from big data or other types of databases. But what we saw is after this initial 2-year phase where these smaller companies had huge success, all the big vendors are now on board. Microsoft, IBM, SAP, all have a self-service BI story. And so the one that we're going to talk about here today is what Microsoft has done in the self-service BI space. But it's all about making the business user more self-reliant, having business users that are knowledgeable and skilled, being able to create their own reports, possibly being able to extract their own data, possibly being able to model their own data, a territory that was unquestionably only for developers before we had this new wave of tools. And so one of the goals here is to have project results in weeks, not 6 months, not a year. So what you'll find when you start using these BI tools is they're incredibly powerful. Now, if you look at a BI project, we can basically break it down into these 4 roles. You have the BI consumer. That's your boss who knows absolutely nothing, just wants to see the spreadsheet and wants to see the pie chart with red bigger than blue. There is going to be BI developers and BI administrators. Maybe you're a BI developer, build multidimensional cubes. The self-service BI tools take a sweet spot where we don't need developers, but there's still, as we move forward, plenty of BI developer opportunities out there. You have administrators that do things like manage SQL, manage SharePoint, make sure they've configured SharePoint so all the self-service BI tools are available. But now there's this BI producer. And that's the power user that is going to embrace the self-service BI toolset in Office, and particularly inside of Excel, and possibly start learning how to make use of that in a SharePoint 2013 environment, and then going forward, making use of it in the Office 365 environment with Power BI. Now, Excel has traditionally been a very strong product for data analytics. Excel is 20 years old, and from the get-go, it had things that were very desired as far as people that were working in terms of data analytics. Over the years, they added support so that you can create a table that basically is a structured set of rows and columns inside there. We have pivot tables, pivot charts that have been there for a while. We have a very powerful cell calculation engine. And over the years, we've also got great support, first to connect to databases, and then to connect to multidimensional cubes, and to basically create your pivot tables and pivot charts based on that. Okay, so now we have Excel 2013. And we have some really neat changes in the product. Well, while you can put tables in a worksheet inside of an Excel workbook, Excel 2013 introduces the idea of the data model as a OLAP database that lives inside of the Excel workbook file. So how many rows can you put into a table in an Excel workbook? Basically about 1 million. Then you get limited. But the data model gets rid of that limitation. So the data model also allows me to add a second, a third table, create relationships between the tables. And now when I create my pivot table, unlike the earlier version of Excel, you don't have to create your pivot table based on a single table and do all kinds of tricks with VLOOKUPs to make it seem like it's a relational model. We now basically have tables, we relate them together, and the pivot table can be based on basically a model of tables instead of a single table. Now, in addition to the data model, there are these 4 add-ins that basically represent the main self-service BI tools. We have Power Query, we have Power Pivot, Power View, and Power Map. Now, it turns out that Power Pivot was introduced with Excel 2010, but it wasn't part of the installation of Excel 2010. And so when you installed Power Pivot in 2010, it basically installed the tabular database engine. Note that with Excel 2013, you don't have to do that because the tabular database engine is already part of Excel 2013. And one of the problems with PowerPivot in 2010 is if you installed it and you did all this great BI work, and then you sent your boss the workbook and he tried to open it up, it would break saying, you haven't installed the PowerPivot add-on, I don't understand this database inside the workbook. But now, starting with Excel 2013, you enable the PowerPivot add-on to do your work, but now you can send the workbook to anyone with Excel 2013, and because if Excel now natively understands the data model, they're going to be able to get their work done. So in general, it's best to start with Excel 2013 instead of Excel 2010. If you don't have that ability, you just kind of have to expect some bumps in the road as you migrate from one to the other. Power View and Power Map also come out of the box with Excel 2013. The problem with the three add-ins over to the right is that while they're installed, the add-ins are not enabled. So basically, you have to go into Excel, you have to go to COM add-ins, and turn those three add-ins on. Now, Power Query was the one that was late to the party. Power Query in 2013 is kind of like PowerPivot in 2010 because it didn't come with the product. I'm going to look at Power Query first because when you look at BI projects, it kind of makes sense to start with a tool that does the extraction. But what you see is that PowerPivot was initially intended not just to model the data, but to extract the data. And over time, they discovered that they were biting off something that was too big and they needed a separate tool. So they created Power Query, but it wasn't there in time when they shipped Excel 2013. So you download and install Power Query separately. You'll find that there is a new version of Power Query every week or so. So if you're using it, it's going to say update me, update me, update me. And you also have the problem where if I create queries with Power Query, and I put them in my workbook and I send them to you, and you haven't installed the Power Query add-on, you open it up, it doesn't work. So we've got to wait till the next version of Excel before Power Query is as well integrated in as the other three are right now. Now let's talk more about this thing called the data model. So it's basically a OLAP database inside an Excel workbook file. And realize that anything that you import into the data model is separate from anything that's inside of a workbook. Okay, you don't have the million-row limitation. Now, what's inside the data model? Basically, we have tables and relationships between tables inside there. So when we compare this new tabular data model to multi-dimensional databases, it's going to be far more familiar to people who have experience with relational databases like SQL Server, and it's going to be far less of a learning curve compared to working with multi-dimensional databases. Now also, when data loads in to the data model, it gets loaded in memory prior to the execution of any queries. So one of the things that we'll see is the multi-dimensional model builds everything to a cube that's written to disk, and the new tabular model just has everything inside of memory. So you can't say one hands down is faster than the other, but there's lots of scenarios where the new tabular model outperforms the older multi-dimensional model because all queries are serviced from things that are already loaded into memory inside there. Now, when tables load into memory, there's a lot of new technology. Remember the multi-dimensional model in SQL Server was designed around the year 2000, where 4 gigabytes of RAM. Oh my God, how did you get that much RAM? So disk space was cheap, RAM was very expensive, and now this new model is designed 12, 13 years later, when we're going to assume that a desktop can have 32 megabytes of RAM. A server can have 128 gigabytes of RAM. So when it loads things in, it uses a highly compressed format, and it also uses a tabular layout. So think about this. Think about you have customers, and you're loading in 1 million customers from the United States, and we have to store the states in memory. Well, there's only 50 states, so it only has to load those string values in 50 times, and then they just basically use highly efficient integers to map to those things inside there. So when it comes to taking a lot of data and putting it into memory in a very efficient way, and to do very fast query evaluations, the in-memory model, really excels at that inside there. Okay, and once again, this type of database we call the tabular database. Another key feature here is that it just works inside of Excel. But also, there is a tabular model in SQL Server Analysis Services, so we can scale up to the server if we don't have a single user, or we don't have, we have so many users, it makes sense to kind of have a server-side engine running the queries inside there. And it's the exact same model that you create on the desktop that scales up to high-end database servers inside. Okay, now here's just a quick look at a data model that you can create for Excel inside there. Okay, let's keep moving here. Now, let's start with a little ETL for Power Query. Now, once again, Power Query is the new kid on the block. It's the new tool. But I think what you're going to see is that Microsoft has a lot of investment behind this, and it seems to be highly strategic, more so when you move into Office 365, arguably, than it is with SharePoint. Now, when we have BI projects, you have this initial need to discover where the data is, to extract the data, and then there's transformations. Possibly the data has to be cleaned up. Take 3 different values and conform them all to the same value. Replace nulls with blanks or vice versa, things like that. Sometimes what we need to do is take a customer database that just has CA, and then basically merge it together with another one so I can basically have California instead of CA. So there's all types of transforms that we can use as we're loading the data into our data model inside there. Now, in the past, in BI projects, we've needed a BI developer to work with SQL Server Integration Services and Visual Studio to do all this ETL work. And so Microsoft is positioning Power Query as the power user ETL tool. Now, what we're going to see is that Power Query is this add-on that we add in to Excel. Let's kind of start with this. So let me move over to Excel. And within Excel, I just have a brand new worksheet here. And note that once you have installed the Power Query add-on, you're going to see Power Query right here. Note that if update is grayed out, it just checked online and saw that I have the latest version that's available. But the idea is that there's data living in different places. So maybe the data that I want to discover and pull is from SQL Server, Access. You can imagine lots of different scenarios where you need to pull data from here. Obviously, Microsoft's very big on their cloud story. So lots of different data sources that we have from Azure are available. Looking down here, they're also making a lot of strides to do things like seamlessly pull data out of Salesforce into your data model. And I think that will continue where more and more of the places that our data lives, there'll be just very easy ways to get there and import the data inside there. Now, just to show you a real simple example, I'm going to go ahead and import some data from a CBS file inside there, or a CSV file. Sorry, my dyslexia is kicking in there. Let's go ahead and take this CSV file and load it in. So when you pull in data, what happens is Power Query brings this query editor window. It's very hard as a presenter because you have to say Power Query query. Okay, so here's my Power Query query window. And so what are the types of things that we need to do? Well, maybe I want to take this column that was presented to me as first name and last name and split it out. So if I go to the transform and we say split column by delimiter right here, comma delimiter is the one that they choose. They go ahead and split that for me. They give me some names that maybe I need to come through here, rename these particular columns right here, last name, first name, inside here. Let's say that instead of splitting a column, there's 2 columns that I want to join together for my report as one column. So down here, I can also merge these columns together. Do we want some type of a separator inside there? Maybe the new column that we're going to create is going to be hometown. I'll go here and we'll put a comma space inside here. So the idea is we start building these different queries. Look at this, gender. Gosh, I really hate just M and F. When it comes to our reports, what we really want is to have male and female. So once again, if I go down here and there is a replace values, let's go ahead and find any type of F and replace that with female inside. We'll go ahead and boom, it goes ahead and does that replacement. I go ahead, I come up and say, take anything that you find as male, M, and replace it with male inside. Okay. And so we go and we do things like, take something like zip code. Another common thing would be this has been interpreted as a number. I don't want zip codes interpreted as a number because I never add them together. Instead, I want to change the type to something, such as text inside. Maybe I don't really care about hire date. What I really care is, about the particular year that we have inside here. So as I go through, we're going to find as you pick these things and date and year, it just gives you quick ways to do the transforms. Now look at these steps over on the side. Here's what you got to get. When you create one of these queries, there's a set of instructions that are called steps that are applied. And I can go ahead and start looking through what happened when I did that, what happened when I did this, and you can take these and delete them or replace them. So this whole idea of working in terms of steps is important. Okay. Also note that if I go back here to one of these particular views right here and go to the advanced editor, behind the scenes there is this language. The language, I think, was nicknamed M, and then they never came up with a different name, so that looks like the name that's sticking. But the idea is that we have this language, and sometime in the future, what we're going to have is this ability to not have to use the UI, but basically to write code and basically have more reuse. Today, the only real reason you want to work in terms of that is if someone gave you another query and you basically copied this and you created an empty query, you could paste it in. But the fact that it is just a language that can do that gets to be important. Let's do one more example here, just to kind of show you the power of this tool. Okay, now we have height, 6'4", 5'2", but I want to average heights for all these different people, and I can't average something that's not numeric. So let's say I now go to this process of, okay, let's first of all split the column. So let's split the column by a delimiter. And as we split the column, it's going to be a hyphen that we have inside there. Okay, so now we have this first one, which is going to be feet. We have the second one here, which is going to be inches. Okay, and now that we have that, let's go ahead and create a calculated column. So I'll come down here to add column. Go ahead and add a custom column for me inside here. You can see that this new version. Okay, I'm blindly going to think that if I click OK, it's giving me what I want inside there. So the new column, is going to be height. That's great. And then when I want to have height, what am I going to have? We're going to have feet, and we'll basically have feet, and that will be times 12, and then we'll basically add to that the inches inside. Let's go ahead and click OK right here, and I have some kind of error inside that formula. Let me, this was supposed to be my moment of glory right here. Looks like I've lost that, but let's go ahead, move back here to delete. Let's go ahead and delete. So it's easy to delete steps inside there. One more time I'll try this, and then I'll give up if we don't get this. So we're going to have, total. One of the data types was text. That would have been an important factor inside there. Okay, absolutely. Let's switch those things to whole numbers right here. Thank you, sir. There will be something extra in your envelope this week for your help here with me getting through this demo. So now let's go ahead and add this column inside here. Once again, we'll have something like total inches. And so we'll go ahead and we'll add this formula of the feet, and that will be times 12 and plus the inches inside. And now we'll go ahead, we'll add that, and if I move a little bit over to the side, there's that. Okay, now here's the thing that gets a lot of people. We got total inches calculated. Can we get rid of these columns? And your intuition tells you no, because this column is based on it. Yet, we've already run the operation, or the step, to take those two things, calculate something else. So this is a later step. You have no problem coming and removing those columns inside there, and things still work. So, once again, it's moving this logic down here with step by step. So what you see here is just a very powerful transform engine, that is going to be accessible to end users. Now, I need to get on with some other things in the demo, but what you would be able to see is I could take this query and I could save it to the workbook. I could then start building reports based on this. I could also take that data and load it into the data model. So back here in my slides, if you have queries that you're building with Power Query, you can basically pull data from one of the workbooks or from the data model inside. You can pull data from an external system or a CVS file or from Salesforce. And then the output of your query can either be written right into a workbook as a table, or you can write it into the data model. Okay, now, unfortunately, when you're working with SharePoint on premises and you haven't moved to Office 365, Power Query is a client-side only tool, which means you got to have these desktop things running, and you're basically constrained by how much data can be pulled back on your desktop. But once we get to Office 365, once we create the query, we can just tell a cloud-based service to go ahead and pull the data for us, which is going to be far more reliable and far more performant and robust as far as being able to pull data and put it into a middle-tier cache. Okay, now that was Power Query. The next thing we want to look at, and this is probably the most important part of the talk for people that want to get up to speed on the BI stack, is understanding how we model data with PowerPivot. So what we're going to do is we're going to import data into an Excel workbooks data model. And either it's going to automatically recognize relationships between tables I bring in, or I'm going to create them. Now, another thing is, quite often, the databases that you're pulling data from have names that are only something that database geeks find appealing, but business users don't. So when you create the data model, you're creating a facade for your business users. So renaming tables, eliminating tables that aren't necessary for the user to see, renaming columns, adding spaces, all those things get to be very helpful. We'll also create calculated columns and calculated fields. I'm going to go in a little bit more detail about what those are. Just like a multi-dimensional cube, I can create dimensional hierarchies. And then also, you have to understand the whole idea of time intelligence and what that does. What requirements there are. You basically have to add a timetable into your data model to get the time intelligence functionality working. Okay, now, if I worked with a multi-dimensional database, there's this very tricky language which is called multi-dimensional expression language, or MDX. So when we move to the tabular model, we have a language that's easier to use, which is DAX, Data Analyst Expression Language. Now, DAX was written to be immediately familiar to Excel users who are used to writing formulas. They always are going to start with an equal sign, and the one big difference is when you're writing Excel formulas, you reference cells like A1 and C4. And when you switch over to DAX, you never reference cells, you reference basically tables and columns inside there, such as the sales table and the sales amount column inside. Now, calculated columns are created on a particular table. And let's say I'm loading a table into memory. What happens is during load time, it calculates calculated columns. And so after things are loaded in, calculated columns have already been evaluated, so they're very quick to read. Now, we also have something called calculated fields. Now, in many other BI platforms, these are referred to as measures. In fact, the first version of PowerPivot called them measures, and then I guess someone at Microsoft decided that calculated fields was softer and warmer and more friendly for business users. But the idea is a calculated field does some type of aggregate function. It's going to take all these sales totals from individual rows and give us a summation or an average. And what's important to note is that calculated fields are not calculated at load time. They're calculated at query time. And with the column-based format, a lot of these evaluations are very fast. But you can also have scenarios, just to kind of hand-pick a scenario where maybe a multi-dimensional database would be better. I have 1 billion rows, and I have to split that up into 10 subsets of 100 million rows apiece, and we have to go ahead and do a summation of 100 million rows. So with a multi-dimensional database, that could have been done ahead of time and written to disk. With the tabular model, those roll-ups would all have to happen, in response to someone executing a query. Now, when we start working with calculated columns, we kind of do this first demo right here, where let's say that we have something like a SQL Server database, and we'd like to go ahead and create a data model from some data inside there. So the first thing I'm going to do is go over to the PowerPivot tab, click on Manage, and it's going to bring up a separate window. And what you're going to get used to is working with the Excel application window and the PowerPivot window together. Let me close this one down here. Let me also go ahead and save this right here. I'll just go ahead and save the name as Bob. And one of the things that I want you to see is that you have two windows that are both looking at the exact same workbook file. So ultimately, this is the BI consumer view, and this is the view that the BI producer models the data with, creates calculated columns, calculated fields. You can import data inside there. Now, if I say get external data, and from a database and SQL Server, and now we'll come down and I have a local database here on the Wingtip server, and it is the Wingtip sales database. Okay, notice that I have my database amidst all my SharePoint databases. Don't you tell Spence. Can't take his criticism of me if he finds that out. But now what we're going to do is basically say select from a list of tables. So what I can do is I can say, yeah, I want this table right here, this table, this table, this table. Oh, by the way, when I'm doing BI work, generally we want to work at the most granular level. So invoice details is going to give me the lowest level, where I can crunch up totals for product or totals for customers. But invoice details isn't a friendly name. So maybe I'll just go ahead and rename this to sales. Maybe for invoices, I'll rename that one to purchases. The other thing I want to show here is we're bringing in customer data. How many customers do we have? So with Excel and a reasonable amount of memory on your desktop, you can easily deal with tens of millions of rows inside of your data model. However, you don't want to be careless. And so as I look up here, do I want things like first name, last name? You don't want things that are unique. So email address would be something where you would be guaranteed to load 1 million email addresses into memory. So be choosy. Only load in the types of columns that you need inside your BI work. Maybe we'll go ahead and start taking things starting with city and state. But the idea is I go ahead and choose finish. And so now it's pulling the data inside. And I can pull the data inside, and I can build a data model and a bunch of reports on top of that, and then just come back later and refresh the data anytime I need to refresh it. So the whole idea is you build a data model that's refreshable, and then you start building things on top, and then we get rid of this process of, basically Bob builds the monthly report and has to go through the same 143 steps of extracting the data and building everything from scratch. And so this kind of leads to the mentality of build it once and figure out how to refresh the data for the monthly report that you have to write inside there. Now, once we've got the data inside, what we see here is that we can go to a diagram view. And with the diagram view, it always kind of starts in an ugly view, and you kind of have to move things around. And I will say that if you do a lot of work with this, you'll just kind of wish it made these things pretty, and you'll make them pretty, and then you'll add another table, and then it will get ugly, and you'll have to make them pretty again. You can see that when you imported these, it recognized the table relationships in a SQL database, in an Oracle database, in an Access database, and automatically created the relationships. And if it doesn't create the relationships for you, you can simply drag and drop the fields. Well, now you have the view, the table view, or the data view, so you can see each one of these tables inside. So now the things that we do is we start building calculated columns. So now what I'd like to do is, you've kind of seen that initial work. Just for time constraints, I'm going to pull up something that has a lot built into it already. So let me go ahead and now open up this particular view right here. And so this workbook, I've done a lot of work in the modeling space already. So if I go over to PowerPivot, we click on Manage to bring up the PowerPivot window. Some of the things that you see here is that we can have a column that was gender, and I renamed it to gender abbreviation. And then, using DAX, I can basically say if the gender abbreviation is M, make it male. If not, female. I haven't included other here, but some people tell me I should. Okay, also, look at something where I want to calculate age inside here. So if I go ahead and look at some of the things that we have here, for age, I can do something like take the purchase date and subtract the birth date and give me a somewhat crude estimate of how many years old they are. And then once I've got that, let's go ahead and create a second calculated column. And what you'll see when you work with DAX is that we can introduce line breaks and make things more readable inside there. But basically, you're starting to figure out how to create a calculated column to start categorizing the data. What type of buckets do your reports want to break these things down inside? Now, once you've got your data model inside here, actually, let me also look at some of the calculated fields. So if I go over and look at things like sales, you can see that when you have calculated fields, they're not calculated columns, they're down here in this bottom section here. One little trick is that when you're working with PowerPivot and you want to create calculated fields, it's going to be much easier for you to kind of go through the Excel application window and go through this particular view to add these things inside here and to put these in. Okay, now if I just kind of look at some of these workbooks that we have, or some of the the pivot tables, let me start by, if I come back here and I'm inside of the PowerPivot window and I say create a pivot table, it just basically returns back to the Excel application window, and you've either said create a new worksheet or point to an existing worksheet. And so now here is the tables inside your data model. Note that if you have a table where you've hidden all the columns and it only has fields, it kind of shows with a sigma and puts it up at the top. But the idea is that your business users can now navigate through this. Well, I'd like to see sales revenue. How would I like to see the sales revenue? I'd like to see that by age demographic, and I like to go ahead and sort by that smallest to largest. So that's how we start building out data models with this inside here. Now, the next thing that you can see is you can add these things that are called slicers. Slicers are really easy to add in. Here I am, and we'll basically make sure that this pivot table is selected so it knows what data set that you want to add the slicer for. Then we go up to Insert, and what we see is that there is the slicer. So let's go ahead and add slicers, maybe for the product category, or maybe for the purchase year. So once again, a lot of times you're creating calculated columns just to give you a basis, for various slicers inside here. And now we have these things that we can work with, and these are great. They're very intuitive to users to be able to run these right here and remove this inside here. And basically, holding Shift, you can get contiguous ones. Holding Control, you can basically get things that aren't contiguous. So once again, I find these are very intuitive for users. And when you take this and you put it up into SharePoint, the slicers just work perfectly. So it's another huge advantage that they translate, to web pages, with 100% fidelity as far as the user experience goes. Now, we can also create dimensional hierarchies. What do we need a dimensional hierarchy for? So let's say that I go back and we take a look at something like our products table. So the database geeks gave me this one column that had both the category and the subcategory. So using DAX, I was able to figure out how to split out just the category, take the stuff before the greater than sign, and the subcategory inside here. And then by going back to the diagram view, and now if we come back over here and we look at products, note that you can take something like category, you can right-click and say create hierarchy, and then just drag and drop. And the whole idea of one of these hierarchies inside there is that you just give the user a much better experience. Let's say I delete that. We come back over here, and once you create a hierarchy, it just gives the user a single thing that they can click on that allows for further drill down inside there. So things like geographic regions, things like product categories, things like time when you're drilling into year, quarter, month. The fact that you create these different hierarchies just creates a very good user experience. Can you create hierarchies in the multidimensional model? Absolutely. Is it 5 times more difficult? Absolutely. So you see that that was a fairly easy set of steps for a power user when they're modeling data to go through and create. Now, should I keep talking faster? Okay. We talked about categories. Now, next thing is that getting started with DAX, you'll get some success real quickly. Writing some things in DAX is simple as possible. But DAX can get as complicated as you want it to get. You can basically write joins between tables inside there. And so one of the things that we have to come to terms with is this idea of understanding the context. There's the row context, and there is the filter context. Now, when you're doing a calculated column, like look at the first 2 examples. We have row context every time it looks at a row and calculates the value from a calculated column, and the expression that gets evaluated can basically contain columns from the same row inside there. Well, that's great. Now, if you go to a calculated field and you put sum inside there, it's going to give you an error. You can't sum because there's no row context. But there is a set of other fields or functions in DAX that have an X, sum X, average X. And the idea there is that you have to pass a table as the first parameter, then you can have an evaluation inside there. So there is this one function that takes a couple months for most people to really become comfortable with it, but it gives you the most power inside here. For instance, I want to look at product sales, and I can go through and calculate what percentage each product has, or a sales total for each product. But then how do I get what percentage that product is compared to the total of all the products? So what we can do is we can create, if we just create a general sum function, it's going to take the filter context and just give me the summation for that one product. But using calculate, I can say, well, for the baseline sales, let's not worry about any type of filter, any type of slicer, or any other filter they've set. I just want the entire table inside there. So calculate gives me just capabilities to do all kinds of things with a data model that you can't get to in other ways. Now, one last thing that I have to do, and I know I'm going pretty fast here, is to give you an understanding of the time intelligence in DAX. Now, when you want to use time intelligence, step 1 is you have to add a table. Half the world calls it a time table, half the world calls it a date table. You can take your pick. But the idea is that this table will have one row for each day. And when you create one of these timetables, you have to use contiguous years. So don't stop in July, go from the first of the year to the last of the year. And if you have data that spills into 2015, you got to have the time, for the entire year of 2015. But then instead of just having the date, we're also going to have the year it's in, the quarter, the month, and any other way that you'd like to take things and break them down by time. And once you have a timetable inside your data model, there's this whole world of capabilities that we have inside there. Now, inside of this demo, what I'll do quickly is, show that if I go back here to this data model right here, and then we say get external data and from other sources, I have a little Excel file here that is my timetable inside. If I go here, it's basically just an Excel workbook that I've created. You could take timetables, you can find them on the internet. You could create them inside of SQL Server or Access. But the idea is that once we integrate this timetable inside here, we then are going to have to create a relationship to some particular place inside here. So what you'll find is once you add in the timetable, you're going to take the purchase date, and now you're going to go ahead and drop it on the date table inside. And I think I had to go the other way inside there. But now that you've created these things inside, well, we have a timetable. Now, I'm not going to keep doing the demo, but I'm going to go through some slides. Once you've added the timetable inside there, another thing you have to worry about is when you look at things by month, well, February sorts before January. So generally, when you have a column that doesn't sort the way you want to automatically, you add a second column. So generally, January is complemented by another column. I'll call it month sort, which is 1. And you can basically point to a column and say, yeah, have this other column be the column that sorts this column inside there. So basically, you have to configure your sort columns inside there. You have to create the relationship. But once you've done that, you're going to be able to have lots of different ways to look at your data by time. Let me go ahead and close this workbook down and open up a finished workbook that now has the timetable built inside there. And if I now go over to PowerPivot and manage, and we kind of look at the timetable inside, you can see that I've kind of configured all the sorting. Also, we added a dimensional hierarchy for a calendar drill down. So this time, when we go ahead and we create a pivot table, and we want to look at revenue, we want to look at units sold, and then how do we want to look at that? We'll go down to our timetable, and I can either look at things with the calendar drill down inside here. Maybe I want to look at things in a different way. I want to look at things by month. Let's go ahead and remove some of these inside. But let's say that I want to look at sales revenue. And now I want to look at that by the month of the year. And then we'll go ahead and put year up top here. So being able to kind of change things around, gets to be just lots of different ways to slice and dice the data to look at basically any unit of time inside there. Okay, so once again, if I look at these different sample tables, they're all made possible once you've added that timetable inside. Also, there is a host of time intelligence functions in DAX that do not work until you have a timetable. So here's just some examples of using things like total, quarter to date. So I have different functions inside here. And if I go back, get rid of that, and now we just look at things according to the month inside here. What you'll find is I can see things like revenue quarter to date. And the idea is that they'll just be summed up, but then they'll start again in the next quarter, or year-to-date revenue, or if I want to do something real difficult, I want a running total from the first part of the company history. I have to basically write a DAX expression that's going to provide that for me. If I go back over to data view right here, and we look at the running total right here, here's just an example of how DAX can get more complicated. Now, let's say that we want to look at something, and we write a DAX expression to start breaking things down by month. But what if my user basically adds a row filter that looks at that by year or by quarter or by day? All of a sudden, the data that comes back is nonsensical. So sometimes when we write DAX expressions, we say only when someone's filtered this by month do I want to return a non-blank expression inside there. Okay. Last thing to point out is that You can also have KPIs that are just basically calculated fields that you then promote to be a KPI inside there. Okay. Now, spent a while looking at the data modeling capabilities, because I think that's where many people are going to really dig in and provide a lot of business value. There are some tools for creating visualizations, which is PowerView and PowerMap. I'm not going to demo those. I just want to talk about them at a high level. They, in Excel, are based on top of Silverlight. So the first thing you have to grin and bear is that you have a Silverlight dependency, and Microsoft is removing the Silverlight dependencies in the next wave that's in Office 365. So as you use the things inside of your on-premise farms, basically being able just to handle the Silverlight dependency is something that we have to deal with. But if you've used SharePoint 2010, you've probably already gone through the hard knocks of making sure that Silverlight can run on everybody's desktop. PowerMap builds on top of PowerView to build visualizations, but it can take things like cities and states and countries and zip codes and longitude and latitude, send them off to the Bing translation service, and basically then overlay them on top of a map. So just to get a very quick way to visualize a distribution of revenue or expense or number of consultants over a geographic region is something that's fairly easy to do using PowerMap. Okay. Now, the next thing I want to talk about is what happens when you have this workbook inside here. So let's take this workbook that I've been working with right here, and I need to basically upload it to SharePoint. So SharePoint has this facility where, starting with Excel Services 2013, I can just go to a document library right here. And so let's say I go and I find my particular worksheet right here, and we go ahead and we push it inside here. Now, it's one thing when you're in Excel on the desktop and you're running queries, and Excel has basically the tabular model query engine running right on the desktop. So now, what's going to happen here when someone clicks on this? There's no version of Excel running on my desktop, but yet now I have this workbook, and I'm able to start doing things inside here. Someone's hitting a database engine right here. So the way that that works is that whoever configures your farm has to, first of all, install an instance of SQL Server Analysis Services in a special SharePoint mode. Then you go to Excel Services, and you basically reference that particular server on the network. There's obviously some security things that we have to set up. But the idea is that as you upload your Excel workbook with a data model, they take the data from the Excel workbook and basically use it to create a new SQL Server Analysis Services tabular database on the fly. So you're basically just upsizing it, and it's completely transparent to the user. Now, there is a PowerPivot add-on, and there's a lot of confusion there, because just like Excel the desktop, PowerPivot in 2010 is what added the tabular database engine to Excel. Same thing in SharePoint 2010. When you installed the PowerPivot add-in for SharePoint, it added the data model support. It turns out in SharePoint 2013, the PowerPivot add-in is optional because there's built-in support for the data model. So when you install the PowerPivot add-on, it adds basically three things. One thing that it adds is a dashboard and central administration, so the users can monitor things like query performance, responsiveness. And then secondly, it provides this special document library type, which is called the PowerPivot Gallery. And the PowerPivot Gallery, when you upload a workbook, it has this fancy feature of going through, looking at all your worksheets, making thumbnails, and putting them on the page. Once again, this is highly Silverlight dependent. But the idea is that now the user can look at the different worksheets through these thumbnails before the user gets in. So that's a second thing that we have inside there. And then third, it has these fancy little buttons here, so I can quickly create a second workbook that connects to that data model that's in the SQL Server Analysis Services database. Or I can click on Power View Report and instantly create a Power View report. Now, these Power View reports, unlike the Power view reports in Excel that are saved alongside of the worksheets in the workbook file format. When you create a Power View report inside of SharePoint, you're basically going to work with a very similar model inside, but now these get saved to a SharePoint site as an RDLX file. So once again, it just gives you kind of a quick way to grow out things inside there. Okay, so once again, the PowerPivot gallery is optional. Remember that. It gives you the monitoring support and central admin. It gives you the PowerPivot gallery. But you also saw that once you've configured Excel services to point to that, you can just use regular document libraries and get the same net effect. And then it gives you the ability to quickly create other workbooks. And then the last thing that I failed to mention, I'll come back and mention real quick, is that when you have this PowerPivot gallery, you also have a scheduling page to schedule data refresh. So that once you get into SharePoint and the data switches, and you can set up to refresh the data once a day, once a week, once a month. One gotcha there is that if you're using Power Query, and you can basically bring up Power Query on the desktop, fill the data model, push that in, that works great. But once you go to set up automatic data refresh, SharePoint doesn't understand Power Query. So we're hoping that the next version of SharePoint will understand that. Okay, I know we're just about out of time. We're minus 2 minutes until we end here. Give me just 1 second to kind of quickly go through a last set of things with Power BI. Okay, so what Microsoft has done in many areas is turn its attention from on-premises and put all its investment into the cloud. So with the BI strategy, they're no different. They came out with something called Power BI for Office 365 last February, and then earlier this year, they released a whole new set of functionality, which they're calling Power BI. So when you hear the term Power BI, unfortunately, I see certain people at Microsoft just using it as the catch-all marketing term, kind of like ActiveX, something that's been around for 5 years, and now all of a sudden Power BI. But to me, it's a license. You want people to get Office 365 Power BI functionality. Now it's free to certain users because they're in preview, but at some time we're going to pay for it. But really, at the core, it is this service that runs inside of the cloud. And what's really neat is that you can create queries with Power Query. You can save them to a data catalog in the middle tier, and other users can basically harvest those inside. So the Power BI service definitely will see Excel users as the top tier BI producers. But still, it's got other stories inside there because they're also adding support to get rid of all the Silverlight dependencies and start building reports and dashboards for mobile devices. Now, there is a natural query language, and the idea is that humans type English or French sentences, and somehow some engine realizes what you want and translates it into a query. Maybe that will be successful over the next 5 years. I can't really speak to that. But also, if you're comparing, is Power BI and this new move kind of like SharePoint was back in 2007? We had a designer, Power BI designer. So basically, there's this tool that we can have that allows us to create queries, import data sources, make sure data gets refreshed, and then we start building dashboards, which is based on a pure HTML, CSS, JavaScript story. So the idea is that Microsoft is targeting mobile devices and tablets inside there. And the idea is if you build these reports and dashboards with a Power BI designer, that Microsoft currently already has applications in the Apple store for iPhones, for Androids, things like that. So the idea is that we have a common basis. It's going to be easy for them to create lots of different apps to all consume the same feeds inside there. And that's what Power BI is. Anyway, I'm going to be in the Combined Knowledge booth. If anyone wants more information, I will talk slower when you come over and talk to me. Sorry I took you a little bit over the thing, but thank you very much for attending the session today.